Hi, this is Mrs. Vrobel. In chapter 4, we're going to start talking about aromatic compounds. Um, when you think about aroma, you think about something smelling good. Well, the interesting thing about these compounds is they're stinky. They're not a very pleasant smell. Sometimes people feel like they're a little bit obtrusive. Try not to equate aromatic with good smelling. Okay, I'm just giving you a heads up about that. Okay, benzenes are a little bit different from alkenes. So they do have a double bond. We're no longer talking about alkynes, but typically they are circular. I'll show you a model of a cyclic structure that is aromatic. They typically are in a plane, so we're not talking about the tetrahedral arrangement that we've seen in the past. They're conjugated, so they're sort of like a diene, but not. And the really key piece to this is it's 4n plus 2 pi electrons. So if n is 1, that means there's going to be 6 pi electrons. If it's n equals 2, we're talking about 10 pi electrons, and so on. This is called Huckel's rule. Okay, so they're very stable. Your body is full of a lot of interesting aromatic compounds, especially when you're looking at things like steroids, and we'll talk more about that. Probably the most well known is benzene. Benzene is very cancerous, and we're going to talk about some of the polyaromatic compounds that we know are potential health hazards. Highly unsaturated. So that means that there's a lot of double bonds. We're not talking about a lot of hydrogen compared to the alkenes. Okay, we did do a reaction with bromine, and we had a slight change in the consistency, but that was toluene, so that wasn't bromine. I'm sorry, that was toluene, not benzene. Okay, they're not easily oxidized with potassium permanganate. Some of you might have noticed that with toluene there was a slight reaction, but it's a very slow reaction. You probably have to heat it up. They are not like the same electrophilic addition reactions that we talked about with the last chapter. You're going to find a lot of substitution reactions, so we're not going to see the addition reactions. Here is an example of bromination. So you get one bromine substituting one of the hydrogens. Okay, I'm going to skip these sentences or these slides here. So Kekule, I think that's how you say it. I have to double check. He was the first person to analyze benzene in a way that he figured out what the structure was. So he knew it had to be conjugated double bonds, and he was trying to figure out why he didn't see the reaction with bromine, but he knew there were unsaturated bonds there. And the cool thing about benzene is that we have a constant resonance structure. So we see like a flipping back and forth between the double bonds. Okay, so if you look at the bottom there is an example of benzene where the double bonds are flipping into different positions. On the very right, there is what we call a Robinson structure. So it's like a cyclohexene, but not. So that circle tells us that it's an aromatic structure. Okay, the bond lengths are very small, and that's because we have conjugated pi bonds. So it's a very low energy state, and as a result we get resonance. So we get a flipping between the different pi bonds. Okay, let's talk about nomenclature. So there's going to be certain ones that you're going to need to know. In that top left hand corner, that is toluene. Okay, underneath it is phenol, and then off to the right is aniline. So I'll go through some of these with you eventually. Okay. So when you have a monosubstituted benzene, you'll say bromobenzene, chlorobenzene, nitro, ethyl, propylbenzene. Now, when there are two substituents, then you're going to either talk about ortho, para, or meta. So ortho means they're side by side. So they're like carbon 1, carbon 2. If it's meta, it'll be carbon 1 and carbon 3. And if it's para, it'll be carbon 1 and carbon 4. So the top left example is ortho. The top right is an example of meta. And then the bottom one is para. So if you look to the one on the left, it is, and this is a common name, so this is metaxylene. And if you look on the right, that is an example of meta-nitrotoluene. So the CH3 that is directly connected to the benzene ring, that is what we consider toluene, and that was what you were using in your hydrocarbon lab. Now, if you have more than one substituent, then you have to start numbering. So notice that in this one, it's 1,2,4-trimethylbenzene. So very similar to what we've been doing. Okay, so what I need you to do now is I have a worksheet for you in Canvas. So go ahead and download that. And I'm going to give the substitute teacher a key so you can check your work and see how you're doing.